Hello, good morning, afternoon, whatever time we're doing this. Just want to finish finish circle theorems. We're going to do the next bit actually. There's one more topic to cover, but just want to round this up. So this is all the circle theorems to do with tangents to a circle. Okay, so there are three of them. Two are fairly simple. The last one gets trickier. So as usual, we start with the circle. That's the center of the circle, and we're just going to pick a point outside the circle there. From that point to the circle, I can draw one and two tangents to the circle with the point of tangency there and there. Well, what you need to know is that any two tangents drawn to a circle from a point outside are the same length. So from that point to that point, and from that point to that point is the same length. And in the exam, when they ask you for reasons why your answer is whatever it is, you can say, this is the magic words you need to write down, any two tangents to a circle from a point are equal length or the same length, something like that. So that's the first thing you need to bear in mind. The next thing to bear in mind is the radius to the tangent always meet at 90 degrees, always. And in the exam, when they say reasons for your answer, you have to write down that the tangent to a circle and the radius always meet at 90 degrees. Again, I've got another point of tangency here. I could draw another radius. Well, the tangent and that radius are also going to meet at 90 degrees. That's another thing you need to know. Now, in the exam, very often, they like this kind of question because if you think carefully, this radius and that radius are the same length as well to each other. So think about what quadrilateral have I got there? This side is the same as that side is the same as that side, these two angles are equal to each other. That is a kite. It's a kite. So all the angles in the kite add up to 360 degrees because it's a quadrilateral. And you can see how they may throw different questions there. They may give you that angle and ask you to find that one there. So you know these two are 90, 360 minus 90 minus 90 minus that will give me that angle there. So if that was 120 degrees, this angle here would be 60 degrees. Or they could throw you two chords there and ask you for the angle up there. Well, you know that angle at the circumference is half the angle at the center, so that'll be 60 degrees. So there's loads of things that they can do with tangents and the tangent and the radius meeting at 90 degrees. Okay? Fantastic. The last theorem that I want to do with circles and tangents is called the alternate segment theorem. And this is the only theorem in the exam when, if they ask you for reasons for your answer, you can outright say these two angles are the same because of the alternate segment theorem. Okay? So let's have a look at what the alternate segment theorem looks like. Circle, circle. Tangent, tangent. You're always going to have a circle and a tangent. Now, from the point of tangency, I could draw a triangle. It doesn't have to go through the center. It could be anyway, so long as the three vertices of the triangle are on the circumference of the circle. Okay? But what the alternate segment theorem tells us is that this angle here between the tangent and the triangle is equal to this one over there. Those two angles are equal. And by the same argument, this angle here is equal to that one over there. And that is because the alternate segment theorem. So if this blue angle here is 40 degrees, that is 40 degrees. And if this is 60 degrees, that is 60 degrees. Alternate segment theorem. And that's the last thing to do with tangents and circles. Now they can mix them all up. They can come up with loads and loads and loads of different questions. Mix 1, 2, 3 circle theorems together. These can get pretty complicated pretty soon. And it's a matter of practice, which you're going to get loads of, or should do loads of. Anyway, take notes, watch it, copy the examples, and then let's get to it.